After half a century, NASA has plans to return to the moon.
The Orion spacecraft is the vehicle that will take them to the moon.
While other players in the space industry set their eyes on Mars.
Clearly the real objective was Mars, and it's where the future is. It's the planet that has on it all the materials needed to support not only life, but human civilization.
Each breakthrough brings humanity one step closer to becoming a multi-planetary species, exploring further than we've ever gone before.
I think ultimately the Artemis program is really just about humans' enduring drive to explore. Hopefully through the Artemis program and through Orion, we'll unlock some secrets to the universe.
I'm Krajnovic.
And I'm Myrna James.
It's time to go behind the wings.
In this episode, we're going to explore the question, back to the moon or straight to Mars? It's not the first time we've been to the moon, but this time it's going to be different.
It's been over half a century, and it will be different. It's about going back for good to, set up a lunar base, the cislunar economy, a gateway. There's still a lot to learn.
It's really incredible. Artemis is NASA's plan to put people back to the moon and possibly be a base to go to Mars.
To start off, we talked with Mars Society founder Dr. Robert Zubrin, who's been thinking about pushing the limits of space exploration since he was a kid. Why is space exploration important, and how did you first get started?
Why is space important, and how did I get into it? I was 5 when Sputnik flew, and while the adults may have been terrified of Sputnik, I was delighted with it, because what Sputnik said to me was this was going to be true. This was the future, going to move into space, and I wanted to be part of it. Reflects a child's delight with the possibility of an exciting and amazing future. That is what we need. We need an exciting, amazing, lively, optimistic future. If we can expand into space, then we can all understand that there's no reason to kill each other fighting over provinces if by working together we can open up planets.
Welcome to Lockheed Martin. Thanks for joining us today.
Yeah, I'm happy to be here.
Kids are unique in that they just have this innate curiosity and wonder and sense of exploring. It's something that we sometimes lose as we become adults. They walk outside, they're the first to look up at the sky and to point out the moon. They just want to ask why. They just want to explore and understand things and see what's next. And I think on us as adults, that's part of our job, is to keep fostering that sense of curiosity and that wonder. I'm Heather McKay. I'm the Engineering Development Senior Manager on the Orion program. Astronauts have been to the moon before on the Apollo program, but really that was just the initial step when it comes to exploration. There have been many famous explorers in the world. You think about Lewis and Clark, Magellan. And just imagine if they turned around at the first obstacle or even the first island that they found. And that's kind of where we're at with space exploration. The Apollo astronauts were great explorers, and Artemis plans to really pick up where they left off.
The plans to go back to the moon are ambitious. Everything they want to build there, the infrastructure on the moon, is going to take a lot of launch capabilities.
Yeah, it's a lot of mass, it's a lot of capacity, and the early rockets, they had trouble even just reaching that escape velocity, right? How fast you have to be going to escape the gravitational pull of an object. And this plan just takes that to the next level. You're not just launching people, you're launching all the infrastructure to build a permanent base on the moon. It takes some big rockets, like this one. We've gotten in touch with Tory Bruno. He's the CEO at United Launch Alliance. They're building the upper stage that's gonna take humans back to the moon for the first time in half a century. We'll meet him at the Mission Control Center. I think he can tell us what it's all about.
Last time we went to the moon to explore it briefly, to go there a few times, and then we stopped. This time we're going back to stay. I'm Tory Bruno, the President and CEO of United Launch Alliance, and for the balance of our time together, I'm your personal rocket scientist. A big difference is since the last time we went in the Apollo program, and mostly in the upper stages. So today we can fly much more complicated missions. When that Saturn V went to the moon the first time, it was a big deal that the third stage with its J2 engine could actually burn twice after a short coast. Now we can do lots and lots of burns. We can do long multi-hour coasts in between, and when we put that together With the tremendous computing power we can put on a rocket today, we can take more mass there, we can go faster, it's safer for the crew. So those two big technologies, the advanced upper stage and these powerful, powerful computers, I mean, your watch has got as much computing power, if not more, as we went to the moon with the first time. Imagine what we can do now.
In Greek mythology, Apollo had a twin sister. Her name was Artemis. And this program is named after Artemis, the goddess of the moon. And it's apropos, given the time, Artemis and the Orion spacecraft will carry the first woman and the first person of color to walk on the moon. We are the Artemis generation. With the Artemis program, NASA plans to build a sustained human presence there. And the moon has so many interesting things. It's got interesting geology and craters from when the universe was first created. It has water ice that we can use for future fuel and propellant on future missions. And ultimately, it's this proving ground where we can test out our equipment and our technologies and our tools to prepare us to send humanity deeper into space.
This is very much an important moment in human history because it's going to change the destiny of our species. As we sit here on Earth today, we're living on a planet with limited resources, and we're putting a lot of attention and our thought into how do we live a smaller footprint to extend the inevitable consumption of our planet's resources and the collapse of our society and our civilization. This changes all of that future for us. There is incredible natural resources on the moon and on the asteroids or near-Earth objects, as we call them, that are within easy reach of the moon in this greater space we call cislunar space. There is such an abundance that it literally defies human imagination. And when we are able to tap that, it changes everything for us. A post-scarcity human future is what we're looking at. You know, putting a 50-story building on a launch pad that is 90% high explosive to just break the bounds of gravity, right? Defying the tyranny of our planet's gravitational force to hold us down is impossible, and yet we do it all the time. It's become routine. When we look to the potential future for humanity and for the entire globe that exists through the moon, through that gateway to these resources, you're just so inspired by it. You're not daunted. You just have to go do it.
We're here in Houston, Texas, home to Johnson Space Center, NASA's Center for Human Flight. There's so much cool space stuff here that in 1967, it earned the nickname Space City. We met up with Jim Jeffrey, who works on the Orion spacecraft.
My role is to be the vehicle integration manager for Orion's spacecraft program. Orion is the spacecraft that's going to take humans back to the moon for the first time since early 1970s, and they'll do so on the Orion capsule. Starting with the International Space Station program, we've had a continuous presence in orbit for over 20 years, and we're using that to develop long-duration technologies, understand what it takes to keep humans alive for months in space. And now, this summer, we're going to launch the first Artemis mission. Artemis 1 will be a crewed test flight, could be 4 to 6 weeks long. And what we're going to do is launch the Space Launch System and Orion for the first time and take it out to lunar orbit. We'll test out all the technologies that are needed for safe crew exploration and demonstrate that we're ready to put humans on board on Artemis 2. One of the hardest things about the Artemis program is the integration. All the different pieces coming together at the same time to accomplish one job, launch our astronaut crews to the moon and back. And so that requires a lot of integration, coordination, and communication across the country and really across the world with our European partners. They're all contributing to help Artemis be a success.
The Orion spacecraft is very complex. It has thousands of parts, and it's specifically designed for these very complex missions to deep space. So this is a small-scale mock-up of the Orion spacecraft. You can see some of the key elements. The big blue things are the solar panels, so we can provide power in deep space. You see the small squares, those are the windows, so the crew can look out and see where they're going. On top of this would be the launch abort system that jettisons at launch. It would reveal the docking system so we can dock to the gateway and the human lunar lander. On the back end would be the booster, that Space Launch Systems that falls back to Earth once it does its job on launch. It's really a state-of-the-art spacecraft and part of the next era of human spaceflight. Lockheed Martin is the prime contractor to NASA building the Orion spacecraft, but it takes a whole team around the world to make it work. Lockheed Martin has over 2,900 subcontracts with businesses in every state of the country, many of them small businesses. We also have international partners. The Europeans are building the service module. Men and women are working hard all over the country to building the spacecraft, getting it ready to take people to the moon.
It is so cool to be going back to the moon with people after half a century of not being there. ULA is participating in a couple of different ways. We're going to fly one of the early robotic uncrewed missions, something called the Peregrine Lunar Lander, which is really cool in itself because it's the first commercial lander to the moon. And then we're also part of SLS's first missions. We're providing the upper stage, the interim cryogenic propulsion stage for Artemis. So we're just really excited to be both a part of the uncrewed missions and part of the activity leading to the crewed missions when people will go to the moon and put boots in the regolith finally after 5 decades.
The Space Launch System is a very versatile and capable system. It was developed using systems that are derived from the Space Shuttle program. The solid rocket boosters that people are familiar with, the big orange tank in the middle that holds the propellants. The main engines are formerly known as Space Shuttle main engines. So using the development work we've done previously in that flight experience, we're now using them in different ways in order to support a different mission, deep space exploration. So the SLS is capable of launching the Orion spacecraft. It's also capable of developing a cargo configuration where we could put very large payloads into space.
There'll be a space station orbiting the moon. There'll be permanent facilities on the moon. There will always be a continuous human presence on or at the moon, much like the International Space Station today. That means logistics is everything. There's cargo, there's fuel, there's water, there's trash coming back, there's toilet paper and coffee. This is going to be a huge job to support those people who are exploring this really important body right here, just a week away from where you and I are sitting here in our control center.
We're in the operations center, and what exactly goes on in here? Because I imagine on a launch day, we have lots of chairs and computers. They're usually full of people.
They are. There's a person in every chair on every monitor, and this room is actually supporting the mission control center that would be down at the launch site. These are full of engineers. Every part of the rocket has an engineer personally responsible for it, and they're on this during the countdown. They're monitoring telemetry on the pad from their equipment. Wow. They can, on these screens, get all the data for that piece of hardware since the dawn of time. They can make sure everything is good, and if it's not, they'll huddle up in this room and they'll solve problems.
And give me a sense, what would this room look like on Artemis 2 launch day?
You can see the headsets, they'll all be on there. They'll have all kinds of data on their screens. They'll be talking amongst themselves, making sure everybody's comfortable or solving problems. You'll hear comms going back and forth. Like these little devices will allow us to tune into different channels. There's so much happening. It's a giant orchestrated effort.
So many firsts have happened in here, and with the Orion and with the Artemis missions, there's going to be more. Do you ever get used to it?
No, never. So we're at over 140 launches now. We'll be up over 150 here shortly here at ULA. I personally, across my career, have done close to 400 launches. And I'll tell you, it never gets old. It never gets routine. I get butterflies every single time.
Wow.
There's nothing like it.
Well, Tori, thank you very much.
Thank you.
I think we're in the early stages of space exploration. There's a lot more to learn about how to operate in a deep space environment for similar lengths of time. We're developing now the systems with Orion to take people to deep space exploration destinations and bring them back. So the upcoming Artemis missions will be the early demonstrations of those capabilities, but there's a tremendous future ahead for us to go explore.
My name is Jackie Mahaffey. I am the Chief Training Officer for the Artemis 2 mission, so our first Orion crewed mission. And my job is to lead the development and execution of the training of our astronauts that will be on that mission, as well as the simulations that we will provide for the mission control team and when the mission control team practices with the crew together. All of the astronauts that we'll be taking for our Artemis missions will have had our astronaut candidate training or equivalent if they're an international partner crew member. So we have some baseline that we can expect from them in terms of understanding spaceflight, understanding how teams work cohesively, and then from there we look at what are all the different tasks that the crew is going to have to perform on the mission.
So the Orion spacecraft, this is a big part of their training. Should we take a closer look?
Yeah, let's grab our helmets and head in.
All right.
You can see the 4 seats and the configuration, they have them here. What you may not be able to see, if you look behind you, you can see, are the display units. So these seats here are for our commander and pilot, and they will be, during pre-launch and during launch, monitoring the data coming from the launch vehicle as well as the Orion vehicle, and just understanding everything is going well or communicating with mission control about something that may not be going as planned. First couple missions, Artemis 3 in particular, will be about proving our capabilities to land on the moon and exercising all of the new equipment, new spacesuits we have to go explore the moon. Artemis 4 folds in the gateway, that outpost that will be around the moon. You know, we're going to practice having that as an outpost to support our lunar missions, and we will learn a lot about how we can use an outpost like that to help support our missions to Mars one day.
This is basically a deep space station. It's a much smaller version that will orbit around the moon. It'll allow astronauts to do extended missions above the moon, to and from the moon, and for Orion to dock and return. When they're not exploring the moon or in Orion, they'll be able to do this deep space science that will enable us to further explore deep space.
So once the astronauts are suited up, one of the first things they'll do is come in and get strapped in the seats.
Mm-hmm.
Is that something we can try out?
Yeah, sure.
So how do you get into these seats?
Put your feet up on the footrest. I have a little extra strap with me.
And I mean, now it feels like a very kind of awkward position, but if you're in zero gravity, it won't feel quite so awkward maybe.
Yeah, although remember, they'll be in this position for launch and entry. This is like the total extent of switches, which if you've ever seen the inside of the space shuttle, it was covered with switches and circuit breakers, and so most things are operated through the display panels.
It is just really cool to think that this is kind of the setup and situation that the next humans are going back to the moon and maybe one day Mars. So that was really cool. Thanks for showing me.
Yeah, absolutely.
All right.
Watch your head. For me, going back to the moon after 50 years means a lot because my generation never saw that happen live. And I grew up knowing the space shuttle and being familiar with it, seeing us be on ISS on the space station for over 20 years. And those things feel very normal. But knowing that this really cool thing happened and never having seen it live, I'm personally really excited about, like, let's see it happen again. And then let's do even more.
It's a big question. How do you decide Moon or Mars?
There's really 2 main camps to answer this question. The first camp, of course, is NASA and the Artemis program, with an incremental stop at the moon in order to get to Mars. But that way people can get used to living in space and they have this incremental option. And the other option is straight to Mars.
Straight to Mars, it sounds pretty good to me if it's doable. It's not really a new idea. Robert Zubrin and others actually proposed this in 1991, something called the Mars Direct proposal. And part of it is the idea that Mars is just a very interesting planet to go to, the atmosphere. There's a lot you can do there. You can make the fuel, you can make water, and it sounds like a good place to live. You know, today Elon Musk and others have kind of adopted their own version of it. Elon with SpaceX and Starship, which is the ship they're building to make trips to Mars. So the Mars dream is not dead in general and for NASA as well.
Do we go right to Mars? Do we go back to the moon and then go to Mars? I'm more of a moon
first guy only because it seems, somewhat kind of serendipitous that the moon is there, 2 days away instead of 200 days away. The moon has, a sixth of the gravity of Earth as compared to Mars having a third of the amount of gravity. The moon has no atmosphere, which in some ways can make things easier. Other things makes more challenging.
The moon holds a lot of secrets. We want to go to new places on the moon that we weren't able to explore during the Apollo missions. Places where the sun has never shone, and we may find early parts of the solar system captured in these extremely cold craters around the moon.
While Orion has been built for the Artemis program and these lunar and deep space missions, ultimately we believe it has a place at Mars too. We believe the Orion spacecraft can be used for up to 1,000 days, which is just about how long it would take for a mission to Mars. And Lockheed Martin has this concept called the Mars Base Camp, where it uses Orion as a cornerstone and then adds habitats and other things that are needed to explore Mars. It might be possible someday we need or want to become a multi-planetary, faring species. And along the way, we'll do some interesting science and we'll develop technologies that will help us here on Earth and inspire the next generation.
It seems like the moon was perfectly placed for us to practice, to learn things that will help us go to Mars someday. Now, having said that, it's expensive. And, if you have to make the choice, do I do both? Do I just do one? How much money do I have? Maybe you could make the argument that, bypass the moon and go on to Mars.
Clearly, the real objective was Mars. Mars is where the science is. It's where we're going to discover the truth about the potential prevalence and diversity of life in the universe, and it's where the future is. It's the planet that has on it all the materials needed to support not only life, but human civilization. For us, Mars is the new world. What's the fastest way there? Mars Direct.
And then a journey into tomorrow, a journey to another planet, a manned mission to Mars.
NASA in 1989, the first President Bush called upon NASA to implement a program, return to the moon and on to Mars, and this time to stay. It was the 20th anniversary of the Apollo moon landing, and that's how he celebrated it. And so NASA went off and developed a plan that was gigantic in its cost and schedule. They're making this much more complicated than it needs to be. It's like, designing a school play to make sure all the kids have a part. It's great for school play, but when you're talking about tens of billions of dollars, it starts adding up. The concept was immediate, caused a lot of excitement, and it immediately became controversial. There were a lot of people in NASA and even among our competitors who thought this was great. This is a way we can actually get to Mars. Technologically speaking, it was within the realm of our technology in 1990 when we came up with the plan, and it still is. Along comes Elon Musk. Now, he's certainly not interested in doing things to spend money. He's interested in spending money to do things. So he has embraced a version of the Mars Direct plan as the basis for his plan for human Mars missions. The designs of the vehicles are different. They're his own designs. And there are certain aspects of the plan that are different. But it's basically direct flight to Mars, no on-orbit assembly, no need for other orbital infrastructure, and direct return from the surface of Mars using propellant made on Mars. That's Mars Direct. That was the plan that Baker and I laid out in 1990, and that is the plan that Musk has embraced in his own way today. We are most likely to get to Mars this decade. Once Starship becomes operational, Starship uses methane oxygen propellant, and that is why it uses that instead of other possible propellants, because it's the propellant you can make on Mars. Heavy lift vehicles using propellants that could be made on Mars, regularly flying to Earth orbit with payloads comparable to that of a Saturn V moon rocket, but 1% the cost because it's reusable. He's got the transportation system, that's the main thing. We develop everything else. Put this together, a public-private partnership, we could be on Mars before the end of this decade. And that is what I think will happen.
My name is Dr. Shannon Rupert, and I'm the director of the Mars Desert Research Station. The Mars Desert Research Station was built to study what life would be on Mars, how we as humans would not only live, but explore and do science. We're in a true geologic Mars analog. What that means is that you see the same patterns and processes in the geology of the area where the station is set that you see on Mars. The idea is when you put humans on Mars, they can get so much more information than we can get from a single robotic mission.
We asked so many people in the space industry what their dream is for the future of space exploration. Engineers, astronauts, entrepreneurs, historians. It's a great question because there's not just one answer.
My hope is that NASA and the Artemis program can help make humanity be a multi-planet species.
I want to see the space industry get to a point where we can access the infinite resources of space.
Just forget about Moon and Mars. I think we are on the upward swing of more common access to space than we've had previously.
Ordinary people like you and I will live and work in space because our jobs are there and we can have a better life there.
There are so many smart people working on this question, what is the future of space exploration? And the only way that we can realize that future is by dreaming and working together.